Okay, on this lesson, we're going to be looking at another way of dividing polynomials. So instead of using long division, we're going to use synthetic division. So synthetic division is an alternate process to polynomial long division that may be used for problems with divisors in the form x minus a. Notice that it says x minus a. All right, it is streamlined process is faster to execute, but it is not suitable for all polynomial division problems. So it will definitely be easier. Okay, so now let's look at our process. So this process, we're given an example here. Notice this is similar to what we have when we were using long division. Okay, so you're first going to write the quotient as a synthetic division problem using coefficient of 0 for any missing terms. So make sure you always use 0 for missing terms. You're going to line the coefficients. Remember, coefficients are the numbers in front of your variable of the dividend across the top and use a from x minus a in the divisor spot. Notice its sign is the opposite from the divisor. Okay, so notice here we have x plus 6, but on the form it says x minus a, so that would be a negative 6. That's why there's a negative 6 there. Then we're going to line up the coefficients. So the coefficient of x cubed is 1, x squared is 2. Notice there's a missing x, that's why it's 0, and then the constant's 1. So you're lining up your coefficients. Then notice it says bring the first interior coefficient down. So that's how you're starting it. You're bringing the first one down. Then you will multiply those together. So negative 6 times 1, and you're going to put the answer underneath the next coefficient. Then you'll be adding these together. So 2 plus a negative 6 gives you a negative 4. Then you'll start over. Multiply these together. That answer goes here. You'll add those. You get 24. Then you'll multiply these together. You get the negative 144. You'll add those. And the last one is always your remainder. So always start on the far right underneath the line. This first one's going to be on the far right is going to be your remainder. And then the next one will be the constant. That's what the C stands for. The next one will be your x coefficient, x squared. If you have anything else, you'll just keep going. So once you get to this point, then you can write your answer, which is very similar to what we had when we were using long division. So let's try an example on our own. So first we're going to set it up. So this right here, remember it's x minus a, so a is going to be negative 3. It's the opposite. So I'm going to put the a here. And then I'm going to draw my line here. Okay, so all my coefficients go in this top row. So x cubed is first, so that's a 2. After x cubed, we should have an x squared, but there's not one, so make sure you put a 0. And then x would be 1, and then our constant's negative 3. So really the common mistake on these is forgetting the 0 if there's something missing. So to start this, we always bring down the first coefficient. And then we're going to multiply these together. So negative 3 times 2, we get negative 6. Our answer goes underneath the next coefficient. We are adding these together. So that's going to be negative 6. We'll start over, multiply those. We get 18. We add these. Don't get that confused there. We're adding these. So that's going to be 1 plus 18, which is 19. We'll keep going. We'll multiply those together. And then you should get negative 57. And then we're adding those last ones, and we get negative 60. So remember, the last one, start the far right. The last one is your remainder. I'll use a different color. The last one is the remainder. The next one to the left of that is the constant, then your coefficient of x, and then your coefficient of x squared. So again, always start on the far right with the remainder. Keep going this direction. Okay, so let's write it. So I'm going to have a 2x squared, because that's my coefficient, minus 6x plus 19, and then plus our remainder. Our remainder is negative 60. Remember when we were using long division, it's always out of your original divisor. So x plus 3. So if you had used long division, you would have ended up with the same answer. So this is just another way of dividing polynomials. Okay, let's look at the back. Okay, so in order for this video to be shorter, you're welcome to try this. You can use long division, synthetic division. You should be getting the same two answers. All right, so there's another way of evaluating polynomials. Okay, so in order to evaluate polynomials, this is going to be called the remainder theorem. States that if a polynomial f of x is divided by x minus a, then the remainder is f of a. So that's just function notation. You're going to substitute your a in for your x on your original function f. This means that synthetic division may be used to quickly evaluate polynomials. Okay. All right, so first thing we're going to do on this example is we're going to evaluate this using substitution. If I know f of 2, or I'm looking for f of 2, remember we talked about this before, that means x is 2, and I'm going to substitute it into this function. So in place of all of my x's, I'm putting a 2. So I'm going to work it out. Order of operations, you have to use or get rid of the exponents. So that's going to be 3 times 2 to the 4th power is 16. 2 cubed is 8. Plus 7, 2 squared is 4. 2 times 2, I'll go ahead and put minus 4 there, and minus 8. So I'm going to continue with multiplying. So that's 48 minus 8 plus 28 minus 4 minus 8. So I'm just going to work my way left to right. So that's going to be 40 plus 28. I'll just bring everything else down. So that's 68 minus 4, which is 64 minus 8, which should give you 56. Okay, so f of 2 just means plug in a 2 for x. You're substituting it in, you get 56. Okay? Now, what we're going to do here is we're going to evaluate using synthetic division like we just learned. Okay? So since our a is inside the parentheses, our divisor is x minus a. So our divisor would be x minus 2. So I'm going to take that f of x. So we're dividing this by the x minus 2. So we are going to use synthetic division. So my a is 2. My coefficients, I have a 3. After x to the 4th should be x cubed. That's negative 1. X squared is 7. X is negative 2. And then negative 8. So I always start with bringing down my 3. So I'm multiplying those. That gives me 6. I put it underneath my next coefficient. I add those. That's going to be 5. Multiply by 2, you get 10. Add, you get 17. Multiply 2 and 17, you get 34. Negative 2 plus 34 is 32. Keep going. 2 times 32 gives you 64, and then you subtract 8 and you get 56, which is your remainder. Remember, this is your constant, this is x squared, and then x cubed. So always start on the far right. Now notice this right here is the same as what we got over here when we just substituted in that 2, which was our a. So when you use synthetic division, it tells you what it is when you evaluate using that a, which in this case, we divided it by x minus 2, which our a was 2. So it tells you what you would get when you would evaluate that. Okay, so let's take a look at another example. So we have g of x and then equals 2x to the fourth plus 7x squared plus 7. We're going to use synthetic division to evaluate x equals -1. So we're not substituting it in, we're going to use synthetic division. Okay, so I know my a is -1. Put your coefficients. We have a 2, it's x to the fourth. Notice x cubed is missing, so I should have a 0. And then 7. Notice my x is missing, which is a 0, and then my constant. So again, the common mistake on synthetic division is not looking carefully to see what variables are missing. All right, so I bring down my first coefficient. I multiply these together, so that's -2. I add these to get -2. Start back over, -1 times a -2 is 2. I add 7 and 2 to get 9. -1 times 9 is a -9. 0 plus a -9 is a -9. And then -1 times a -9 is a +9. And then when you add 7 and 9, you get 16 for your remainder. So using synthetic division, we evaluated x equals -1 by using synthetic division. So our answer, g of -1, should be 16. So we evaluated that without using substitution. If you wanted, you could check it by just plugging in the -1 there and make sure that it gives you 16 at the end. So this is just another way of evaluating. It's also another way of dividing polynomials. If you have any questions, please let me know.